No, I refuse to do that. So, all right. So, some of y'all may live in Anderson, and some of y'all may know the road, Wildhog Road. No, it's not Wildhog Road. It's Highway 187. Shut up. It's Wildhog Road. I hate them people that move in. It's Highway 187. No, Highway 187 is down here that goes to dang old Hartwell, okay? That's Highway 187. Up there at Pendleton, that's freaking Wildhog Road. There's two 187s in Anderson. Okay, no reaction whatsoever. So, Wildhog Road is a very straight road, okay? Takes about 16 minutes. Don't take me 15 seconds to get Pendleton. Yeah, whatever. Indicator, girls, you ever run into one of those guys? Run like hell. Because they're freaking crazy. And not crazy in a good way. Crazy in a domestic violence in the future way. Bet me. Come back 10 years from now and tell me if I ain't right. All right, so there's Wildhog Road at the top. All right, this is the double bridges down here. And if you don't know where the double bridges are, then it's your parents' fault. We're not going to explain it. There's double bridges. Dang old Pendleton, this way. Dang old Garrett's right there. I don't know if it's still called Garrett's, but it's a store. Dang old Portman Marina down there. Go into debt, eating down there. My galley, my daughter works there. Trip her up when she's walking by with a plate of food. Trip her up. Wildhog Road's right here. Dang old Waffle House in Pendleton's right there. Dang old QT right there. Everybody oriented now? Yes. Takes about 16 minutes to travel this road. Okay? When you get on it at the beginning, I traveled it for 25 years, okay, 20 years. And it takes about 16 to 18 minutes, unless you in a time capsule like some of you guys think you are, and you travel it in 5 seconds, okay? But if you're going to class at 7:30 and you have an 8 o'clock class, you will be late. Why? Because every time you get, right as soon as you turn on to Wildhog Road, the little blue-haired ladies club. You know the little blue-haired old ladies? They have a club. Y'all know they have a club, and whenever you're in a hurry, they always get in front of you. Okay? And how fast do they go? 33.5 miles an hour. Y'all know what I'm talking about? Yes. Okay. Y'all not going to say anything. But anyway, that's the little blue-haired ladies club. And it will take you probably 30 to 35 minutes to travel Wildhog. Well, I'll just pass them. That's what some of the dumbasses say. And they end up with a head-on collision because Wildhog Road is a pretty straight road. It's very hard to pass, especially at 7:30 to 8:30 in the morning. Okay? So it's pretty much useless to try to pass. And then you get up here and you say, here's Pendleton High School. Pendleton High School is about a quarter of a mile from Red Light. You get up to about right here, about, I don't know, 200 feet from the red light, and you say to yourself, I bet this daggone person's going to turn left. And there's a little, median right there. And what do they do just as soon as you say that? They turn on their left what? Blinker. Voila! You have just predicted the what? The future. True or false? True. False. Because what? No one can predict the future. No one. Oh, well, there's this lady I know. Well, she's a fraud. Okay? You ever played 20 questions? Some people are good at playing 20 questions. Some people are good at deduction. Some people are good at intuition. Some people can tell if you're coming to them for advice, then you're already in a state of depression. Okay? You think about it. What's the probability of you being in a state of depression? 0.5. So all I got to do is pick one of the two. Yes, you're in depression. No, you're in depression. If you're coming to me for advice, what's that going to tell me? You're probably in a little bit more depression than you're not depressed. See what I'm saying? So I can take these things and I can deduce and I can educate myself on you just by you walking into my office or just by you walking into my, what do you call it, crystal ball, whatever you call it, place. Okay? Now, what did I just do? I just used probability. Nobody can predict the future. And I may have some people, I know a person, ask them one question. That's all you got to do. What's the one question you need to ask them?
Will the lady turn left?
No, this doesn't have anything to do with Wildhog Road. What's the one question? If you ever meet somebody that swears they can tell the future, what's the one question you're going to ask them? Who said that? How did you answer that? You watched the video, didn't you? That's what you would do, right? Common sense. You would ask them, give me the lottery numbers. Oh, well, that's not what I do. No, you don't, because you're a fraud. Okay? Nobody can sit right here and say, oh, the lottery numbers are blah, 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 blah. That's telling the future. You ever seen Back to the Future 2? Forget it. Have you seen Back to the Future 2? I'm not going to ask these characters because all they see is comic book movies. But Back to the Future 2, what did he get in Back to the Future 2 that was so valuable? Not the time machine, but the what? Why? Oh, God, you actually watched it. Okay, why was the sports almanac so valuable? Because when he go back, he could tell the future. Now, that's telling the future. But you have to have some kind of what? Gimmick. You have to have some kind of futuristic look. So if you ever meet one of these nuts that tell you, well, you know what I can do? Write down your dreams, and I can take your dreams, and I can tell you your future. Just hit them in the mouth, because they are so full of it. Why? Who creates your dreams? You do. But you need somebody else to tell you for a fee. You need somebody else to tell you what your dreams are telling you as far as the future goes. Think about that a little bit. What is probability? Probability, and this is a Hubertism definition. Probability is assigning, I don't even know if it's got two ends or not, I really don't care, a number from 0 to 1 to a prediction based on math, in this case statistics, experience, or logic. I asked you about 20 questions. Which one is 20 questions? Math, logic, or experience? Logic. Okay, I'm thinking of something right now. Somebody asked me a question. You know, I can't work in this environment, okay? I can't. Y'all suck. Okay, I'm going to play this again. Thank you. That added to the conversation. Less direct, okay? Ask me a question about what I'm thinking about.
Is it smaller than an elephant?
Yes and no. Another question. It's only yes or no questions. Have y'all never played this game?
No.
It's your parents' fault. Ask a question. Yes.
Is it in this class?
No. Some people do. Yes.
Is it a land animal?
Yes.
Is it fluffy?
No.
Can it swim?
No. Well, maybe.
Is it fleshy?
No.
Does it live on farms?
No.
Is it?
What? A livinism. Okay, in order to play 20 questions, you have to speak with volume and you have to articulate. Y'all sound like Bill Murray on Caddyshack.
Does it fly?
No.
Does it have scales?
No.
Can it get bit?
No. Well, I guess it could get bit. I don't know if it hurt it or not. I shouldn't have said that because I just gave you more information.
Does it have a tail?
Yes.
It's a possum.
It's a possum. Possum has fur. Somebody asked if it had fur. I said no.
You call that fur?
Can it be domesticated?
I've never seen one. No. Oh, it could be.
Is it something you see often?
Huh?
Do you see it often?
Not around here. Maybe in Greenville. No, I'm just kidding. Since it's a metropolis, I want to be. Huh? Yes. Now see, you just asked a very important question. You just narrowed down the whole field between y'all's two questions. You just narrowed it down from a cat or a possum to something that's in the zoo. Keep going. What?
Does it have shell?
No.
Does it have feathers?
No.
Would someone be afraid to feed it? To go in?
Maybe.
Is it an animal?
Yes. You just read my mind. Did she read my mind? No, she didn't read my mind. She just used 20 questions. I don't know how many questions I asked. Now, can you get better at that? Yes. You can get it down to 3 or 4 questions. You ever played spades before? How many played spades before? How good can you get at spades? You can get to where you can throw down one trick, and you know what everybody's got. Same thing with counting cards. Can I tell the future? No. I'm using those 3 things. Well, what's that got to do with Wildhog Road? Well, like I said, I traveled Wildhog Road not 25 years because I'm about to hit 25 years, so I've been here about 5 or 6 years, so about 20 years, 15 to 20 years, I traveled Wildhog Road. And you watch and you experience 20 plus years, okay? Now, what's that got to do with, that mean every time you get on Wildhog Road, you're going to get behind an old lady? No. Where do I live? I live in West LA. West Lower Anderson. Sometimes called West Anderson. Okay? That's why it's called West Side. Okay? West Anderson. Anyway, if you live, how many of y'all would live in West Anderson? Okay? If you want to get to Pendleton, how you go to Pendleton? From your house. Wildhog Road. Okay? You go to Wildhog Road. Okay? 187. 187 is down there where the Bilo is. Okay? Anyway, you go Wildhog Road. Okay? Okay, so that tells me, logically, if anybody's on Wildhog Road, they either live in Townville, because technically the only way you can get from Townville to Pendleton is by 85, of course. That's the only way, and Wildhog Road, because there ain't no road from Townville to Pendleton. Okay? There may be a couple of little roads, but it ain't very, you'd have to go up to 59 and hit 59. You could hit the King of Crossroads. You could go that way, but that's way out of the way. The whole point is there is no other way to Pendleton if you live in West Anderson or Townville except Wildhog Road, unless you go the interstate. So if a person is in front of me on Wildhog Road, then I know that takes care of about 50 questions. This person's either going to Sandy Springs or Pendleton / Clemson. Everybody with me? So logic tells me that this person's going to Pendleton, Clemson, or Sandy Springs. But did you notice that I told you where Pendleton High School was? They passed Pendleton High School. Well, anybody that's familiar with Pendleton High School knows that there's a road, there's about 4 roads on Wildhog Road, that you can turn to the right and end up where? In Sandy Springs. So logic dictates that if I pass Pendleton High School and this person in front of me has not turned right by then where are they going to turn? They're going to turn left because they're heading to Pendleton or they're heading to Clemson. Because they're not heading to Sandy Springs, so they would have already taken what? One of these roads that go to Sandy Springs. So I did not tell the future. I just used experience of where I live and Wildhog Road to tell me that this person's heading to Sandy Springs or they're heading to Pendleton or Clemson. Second, after they pass Pendleton High School, I know they're not heading to Sandy Springs, so therefore all that's left is a left-hand turn. Don't get conned. Nobody can tell the future. But people can use experience, logic, and mathematics, meaning statistics, to see a pattern or to find a tendency. Okay? Does everybody understand that? So if anybody ever walks up to you and says they can tell the future, just go ahead and hit them in the mouth because they're lying to you. All right. So, probability goes from 0 to 1. That means that it's a decimal. A decimal between 0 and 1. Most of your probability areas, probability percentages, is going to equal 1 or 100%. So make sure you make a note of that. In most probability classes, you need to talk in terms of a decimal. So that's a 0.75 probability, or a 0.2 probability, or a 0.68 probability. All right? Halfway is somewhat likely. You got likely. I don't know if it's got an E in it or not. No way. And somewhat likely. And that's at 0.5. Now again, I probably assume that most of y'all know this material because a lot of you have had probability and statistics before, so you should have had this material before. So I'm just kind of glancing over some things. The probability of an event is written like this. Okay? The probability of an event, it could be, some people write it, the event in the parentheses. Probability of a king on a deck of cards. They may write it.
You have a work email.
Probability of a 6 on a die. Okay? Now, a lot of times the mathematics don't get you on these problems. What does? The context of the question. In order to know the probability of a king, you need to know a what? A deck of cards. And if you don't know a deck of cards, then you don't have any idea. Of course, y'all not going to tell me because y'all don't talk. So, probability of an event happening is the probability of something happening over something tried. Probability of something happening over the probability of something tried. So if I flip a coin 50 times, 10 times it may be tails. So the probability of tails in that experiment is 10 out of 50. Again, I'm not going to go into that too much because I don't think I have to. Probability of king, 4 out of 52. And you can reduce that 1 over 13. You know that there's 4 kings in a what? Deck of cards. You know there's 52 cards in a deck of cards. If you don't know that, you need to learn it. Okay? There's a deck of cards up here, and there's 52 cards, and playable cards. Actually, there's 54, but we won't get into the joker and the little joker. All right? But there's 52, and there's a king right there. Okay? So, you need to know about a deck of cards. A die has 6 sides. What is the probability of a 6? 1 out of 6. What's the probability of a 7? 0, because there's no 7 on a die. That's a trick question. It's on standardized tests. People miss it. Okay? Now, I just asked you the probability of a king and the probability of a 6, and y'all told me, and y'all don't have a deck of cards, and you don't have a what? A die. So are y'all magical or what?
Yeah.
Okay. Can you tell the future?
Yes.
This is called theoretical. And I always want to put a H in there, but I think that's the way it's spelled. I always want to put an H after the R. Somebody check my spelling. Theoretical probability is based on nothing but sole mathematics. Y'all knew that there was 52 cards in the deck of cards. Y'all knew that there was 4 kings. There is no cards in your pocket. So anything based on nothing but sole knowledge is called theoretical. Relative is what I call the Mayberry. I call this the Mayberry probability. Why do I use Mayberry? Because Mayberry is what we call modern day utopia. Mayberry is perfect. Okay? Nobody's married, so everybody's in a good mood. Okay? And everybody's happy. Okay? The only married couple in Mayberry, one guy's a drunk, and the other guy, they get thrown in jail for fighting all the time. So all the single people are very happy. There's no crime rate, so nobody gets shot. It's a modern day utopia. It's perfect. I asked you the probability of a king, and you said 4 out of 52. Boom. But that's not the way the cookie crumbles all the time. The opposite of theoretical probability is called relative or physical probability. Physical or relative probability. Anybody know what physical or relative probability is? If I gave you this deck of cards and told you to do it 10 times, okay? You think y'all can handle this? Y'all think you can? There ain't going to be nobody in here to start doing other things while we do this. You think you can handle this? Guys, do y'all think y'all can handle this? All right, I'm going to pass these 4 decks out. Now, I'm going to need a shuffler. I'm going to need a recorder. I'm going to need somebody to do the die. Okay? So, I need one person. Let's see how many people we got here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I need 4 groups, so that's 5. So I need you 5 right here to be in a group. That's 1. So you 2 come up here. And then I need you 2 to come up here. You can be in a group with these ladies. And then this 5 right here. Now, can y'all handle being a set of 6 or 7 people? Can y'all handle it? Okay. And there is a group right there. So shuffle. You gotta find the playable cards. That means you throw the 2 jokers out, the instruction card, and you end up with 52 cards. Okay. Now, those of you Skyping in, y'all grab a deck of cards at home and you can try this and a die. You're going to need somebody to write down some stuff. You're going to need somebody to shuffle. You're going to need somebody to pick. Yeah, just sit down. Take out 2 jokers and the instructions. Move them to the side. Now, what you're going to do with the, and I'm going to write this down because some of y'all are going to screw it up. So let me just go over here. And Each person that's shuffling the cards, you're going to shuffle 10 times. One time between. You're going to pick a card. Well, first of all, you got to ask the group. The group has to say, what are we going for? And the recorder has to write that down. So pick something. Somebody might pick a heart. Somebody might pick a king. Somebody might pick an ace. Somebody might pick a black card or a red card. Whatever you want to pick, that's what you're going for. So I'm going to say, I'm going to pick probability of a 2. I'm going to be just, y'all come up with something, okay? Then you're going to pick 10 times. That means you're going to shuffle 10 times. That means you're going to pick, write down, put the card back in, shuffle. Pick, write down, put the card back in, shuffle. You're going to do that 10 times. You're going to write down the outcome of what you pick. So I shuffle, I get a king. I shuffle, put the card back in, I get a 3. I shuffle, I put the card back in, shuffle, I get a 6. And do that 10 times and write down what you get. So go ahead and do that. Shuffle after you pick something. What do y'all want to go for? Write it down. Just pick something.
Do we put it back in?
Put it back in, shuffle it up real good. Make sure they don't put it on the top or the bottom. Put it in the middle and shuffle it back up. And then write down the next card you pick.
New Facebook comment. Then after you do the cards, pick a number on the die. And then roll that die the same, try to do it the same way every time. I tell people to take a notebook and put it at an incline and to roll it off that incline each time the same way. Just let it slide and do it that way. Or roll it similar the same way. And see, roll it 10 times and write down each number you get.
You can't even roll. Okay.
Now, of course, if you have somebody that can tell the future in your group, then just ask them what the outcome is going to be each time. Now, I will tell y'all tonight, it's going to be a mess. Because it's supposed to get down to 28 degrees. So everything you see out there right now is going to turn to ice. And then tomorrow will be a total cluster. There are going to be people running in the ditch. There are going to be people calling in, asking them, oh my God. If anything ever really happened in South Carolina, we would all just self-combust.
Did we roll 10 times? Yep.
I actually had a student complain that I was teaching gambling. When I first started doing this, I got a complaint that I was teaching gambling. So I guess I'll have to go out and buy everybody a pack of M&Ms and we'll just do M&Ms. I guess that would be okay. No, then the person would call and say they're allergic to chocolate. United States of pansies. I think the United States of snowflakes. There we go. What are y'all doing? You're not supposed to be playing 21. You're supposed to be rolling the die now. Huh? Okay. All right, now, I'm just going to pick one of y'all. What'd y'all pick? I'm just going to pick the front group here. What'd y'all pick? A 4. Okay, the probability of a 4 is 0.16. Now watch this, because this is very important that you understand this. 0.16 or 17, okay? Whatever you want to put. Okay, it's 16 repeated. How many times did you get a 4? 2 out of 10. 2 out of 10 is equal to 0.2, which is not equal to 0.17. Now, they were lucky they got a 0.2. Most of the time, you can't, especially when you do the die, you'll see in just a minute. All right, so what did you pick on the die?
3.
3. Probability of a 3 on a die is equal to 16, which is, 4. I'm sorry, that's 0.17. Somebody do 4 out of, that'd be 1 over 13. What is 1 over 13? Somebody do 1 over 13 for me.
0.07.
Point what? Okay, thank you. So you see, that does not equal that. And that's a 2, not 0.2. Yeah, that's 0.2, sorry. So that does not equal that. Okay? How many times did you actually hit a 3?
4.
4 times. 4 out of 10 is equal to 0.4. Now, then you say to yourself, well, heck, this guy's going to 0.4. So I'm going to bet $100 on 0.4. Do it another 10 times. I'm going to put $100 on 4 because they got it 4 times. Roll it. Now, roll it right now. Don't just throw it. Okay. Because I'm going to get at least 5 4s this time because I got 4 4s last time. So I'm going to get a lot of 4s this time. How many did you get?
So how are you splitting up the 100 just between our?
No, this is just talking. How many 4s did you get? 2. The die knows the die hears what I'm saying. So instead of giving me 4 4s or more, because I expected 5 or 6, it gave me 2. Can the die hear what you're saying? No. Now the point of me asking you to put it on an incline, none of y'all did it, but put it on an incline and to roll it the same way, is because if you did that, you would see that the die hits differently, and that's when you get into combinatorics and chaos theory. Okay? When you get into chaos theory, you can roll that die down an incline, and it will hit a different space on the desk, and it will turn totally different than the previous roll. Okay? Even though you rolled it down the same incline. Does everybody understand what I'm talking about? All right? So there's no way, unless it's weighted, there's no way that these two are ever going to equal unless you apply the law of large what? Large numbers, write this down. Law of large numbers. At MIT, and you can look this up, there was a couple of students a while back that actually took a roll of quarters. Now, how many quarters in a roll of quarters? 40, Hubert. That's right. There's 40 quarters in a roll of quarters. They took each one of those quarters, and they weighed it, and they checked it for balance, and they checked it with a micrometer, and they scanned it with a laser. They did all this crazy stuff with each one of those quarters, and they created an algorithmic quarter based on the measurements they took of those 40 quarters. Does everybody understand what I'm talking about? An algorithmic quarter is a virtual quarter in the computer written by an algorithm. And they flipped that quarter blank times, and the outcome was 0.499999995. Does anybody in here know how many times the computer flipped in the computer to get 0.4999995? Anybody want to take a guess? What? I didn't hear you. 1,000. Nope. Nope.
Twice.
100,000 flips. So, the computer flipped that quarter 100,000 times to get the relative probability to equal the what? The theoretical probability. It took 100,000 flips for that quarter to generate a 0.5 probability. Do y'all see in your experiment that these do not what? Your theoretical probability usually does not equal your relative probability unless you do it 100,000 times, 1,000 times. Now, what does this talk about? What does CYA mean in the real world? Cover your ass. Y'all have no idea what I'm talking about, do you? When you are in a job setting, you always make sure you carry documentation on everything you do. You always, when you're given a project, you make sure you have evidence of what you've done. Why? Cover your ass. Because somebody might say, oh, you stole that, or you didn't do this, or you didn't pull these numbers. Let's say I'm an executive at Michelin, okay? And my executive job is quality assurance. I'm the executive Southeastern Director of Quality Assurance at Michelin. I have a job and an office in the Crystal Palace up there above Greenville on the left. Y'all know where the Crystal Palace is? Anyway, when you pass Carolina Dream, is Carolina Dreaming still open? What's that? What exit? Some of you Greenville fanatics, what exit is that where the Crystal Palace is? It goes back behind and it ends up over there at Haywood Mall. What's that? What's that road? What road is it? It's the road. No, it goes into Haywood Road. Okay, well, anyway, the whole point is there's a big ass building up there, and it's the Crystal Palace. It looks like something Superman would live in. Nothing. Do y'all ever go anywhere? Oh yeah, you don't notice anything. Okay, I'm sorry. Yeah, you don't notice anything. You just tunnel vision. Okay. So anyway, there's this big building up there. You make you make six figures if you work in it pretty much, because you're one of the executives for Michelin. So my job is to predict bad tires for the upcoming year. So I'm playing golf one day, and
and I'm playing golf with some of the executives, and one of them says, "So what do your numbers look like for this year?" And I go, "Ooh, that meeting's coming up pretty soon, isn't it?" And I make up something. And then I go, "Okay, I got to get back to the office and I got to get to work on this thing because the meeting's like next month." So I go to each one of and I pull 10 tires out of each. Greenville, Woodruff, there's one in Woodruff, there's one in Greenville, there's one in Sandy Springs, and there's one in Anderson. I don't know, there may be 2 or 3 more. I don't know. I'm not a Michelin person, so I don't know. But I go to each one in the southeast, and it takes me about a week or two, and I pull 10 tires out of each. I do my numbers, I do my statistics the way I was supposed to, and I got a number. And that number is 26%. So I go to the meeting at the Crystal Palace, and all the executives around, they're giving their report, and it's the budget for next year. And I say 26% next year, we're going to have 26% defective tires. And they put it down, okay, that equals 1.1 million. So they put 1.1 million into the budget for next year. Everybody with me? Next year rolls around. Defective tires was 57%, which equals 26.2 million. Guess what? You're fired. Thank you, one person in the real world. Okay? You're fired. There's none of this misogyny. There's none of this xenophobe. There's none of this racist. You didn't do what? Your job, and you can't cost the company $25 million. You're fired. What did I not do? I didn't cover my rear end. Why? Because I didn't use the law of large numbers. Instead of pulling 10 tires from each company, I should have pulled what? 1,000. I should have pulled 10,000. Now, I didn't have to pull them. All I had to do was go to a computer and say how many tires were defective in this plant in the last 15 days. Okay? I was laxed on my job. This goes back into that decision-making thing that I told you about. You know, we are our decisions. If you choose to go the LAD route and not use CYA, then don't whine when you get fired. Simple as that. The law of large numbers works in statistics, probability. If you want to make sure you got the right numbers, you don't suffer from LAD. Instead of pulling 100 surveys, pull 500. Now, when we get to chapter 7 and 8, we're going to get into how do you pick the size of your group. We're going to get into that. Everybody with me? So you don't have to worry about that right now. But you got to understand, this is the big thing about law of large numbers. The law of large numbers makes this equal to this, or this equal to that, whichever way you want to look at it. Question. Now, there is one other thing that you need to go over before you start working on homework, and that's odds. Odds. And I only care about odds against. Okay, odds against is the probability of failure over the probability of success. Write that down. Probability of failure over the probability of success. 1, and this is in red because these are important notes. Success, I love this. Success is winning. Some of y'all may catch that. Of course, I doubt it. But anyway, success is winning. Now, some of you that grew up in the everybody gets a trophy, that don't work. Okay? That don't work in the real world. If you do the job, you get a paycheck. If you don't do the job, you get what? Fired. That's the way the real world works. And success is winning. So if you're reading a problem, and the problem says, what is the probability of picking a king out of a deck of cards? Then winning or success would be picking a what?
king. You need to write that down because that's the context of the question. Okay, if you're doing an odds question, the question is not going to say, you're going to win if you pick a king. It's not going to say that. It's going to say, what is the probability of picking a king? What is the odds against picking a king in a deck of cards? Okay, it said picking a king. So picking a king equals winning. That means equals success. Picking a king would be success. You have to translate that. Therefore, the complement of winning is not winning. Therefore, the complement would be not
It's currently 9:05
winning.
a.m. With a current temperature of 42 degrees Fahrenheit, today's high is 42 degrees Fahrenheit.
The world will end tomorrow and everybody will run into a ditch, buy milk and bread tonight.
And now, here are today's top headlines from...
Okay? 2. Always do these problems of fractions. Because it's a whole lot easier to work with fractions. So I'm going to pick something right quick to give you an example for your notebook. Probability of a king. Well, the probability is 4 out of 52. Therefore, the probability of not a king would be what? 48 over 52. So what is failure? 48. So that would be the odds against is equal to 48 over 52 divided by 4 over 52. And what do you do when you divide by a fraction? Multiply by the reciprocal. And they cancel. That's why you use the fractions. So you cancel and you get 48 to 4 or 12 to 1. I think it's 12 to 1. Yeah. So if I make a $500 bet on a king and I pick a king, somebody multiply 500 times 12. What do you get?
6,000.
That's what I thought. I just won $5,500. Now I'm going to say one more thing here. There's 2 entities in life that are not into worrying about your pocketbook. One is the bank / insurance companies because they do the same thing. And the other is Vegas. Okay? So if the probability, I'm going to write this on the next page. So go ahead and write that down because I need to shut up. Okay? Everybody got that? If the probability is low, the probability of winning is low, the odds against are going to be what? High. If the probability of winning is high, the odds against are going to be what? Low. Because the bank, the insurance companies, and Vegas do not want to give you what? Their money. They want to what? Your money. They want to take your money. We will do this with the roulette wheel, and I did it in the video with the other class, so you can watch it, kind of get ready for class Tuesday. But we're going to do the roulette wheel. Any questions so far? So you should be able to handle 5.1 material now because that's what I just went over. Let me shut off the recorder and I'm going to take the roll.